Good day everyone, we are Team Task Together from the STIW3054 Real-Time Programming Project. I'm Xing with mention number 287777. Leading our group is Tyng, and joining me are my fellow group members Wong Cheng, Jing, Ying, and Hui. Now, let's divide into the details of our project titled GitHub Monitor. Our project is rooted in the enhancement of the event involving landscape of contemporary software development. In this dynamic environment, certain key elements has risen to prominence, reshaping the web application are designed and deployed. Among these, real-time data processing, the adoption of distributed system, and the implementation of application containerization has become pivotal aspect in ensuring the efficiency and scalability of modern software solutions. Moving on the proven statement, conventional manual approach to managing the complexity of real-time data processing, distributed system, and application containerization have proved inadequate. The challenges of handling this issue manually result in delayed response and a higher likelihood of errors. Recognizing the need for a more sophisticated and efficient approach, there is a demand for systems that can streamline data collection, processing, and analyzing in real-time scenario. Therefore, in response to the identified challenges, our project aims to construct a comprehensive system designed to address the complexity of real-time data processing with a specified focus on GitHub issue. The core component of our system include the integration of Apache Kafka for efficient real-time data processing, coupled with the utilization of a Telegram bot for displaying process results. To ensure the persistent and facilitate robust management, MongoDB is incorporated as our chosen database solution. Furthermore, the entire system is encapsulated within Docker container to enhance portability, scalability, and ease of deployment. That's all for me. I will pass it to another group member to continue presenting.
Greetings to Doctor and my fellow classmates. I am Yin, matrix number 287456, and will continue with the methodology of our project. To achieve the purpose of our project to collect real-time data and display the processed information to the consumers, we begin with the installation of Apache Kafka and Zookeeper to manage distributed brokers. We will need to start the Zookeeper and Kafka using command prompt before we could proceed with the application. We will be having two producer applications developed using Python programming language to fetch GitHub issues in JSON data format using the GitHub API. The fetched data will then be transmitted into two Kafka topics created by Kafka brokers. The stream data will be analyzed and the number of active commanders and word count will be calculated. The number of active commanders and word count will then be transmitted into the Kafka topics. We have chosen the MongoDB as the additional technology in our project. Hence, the MongoDB will be employed to store the data processed by fetching them from the Kafka topics. We created a database named GitHub Analysis, and there are two tables in the database. The first table, word count, is to store words that appears frequently and their number of occurrence, while the second table, active commanders, is to store the name of the commanders and the frequency they have commented on GitHub issues from both repositories. Next, we will configure a Telegram bot by acquiring credentials from Telegram bot father and set it up to interact with the consumer application. The consumer application will extract data from MongoDB and send it to the Telegram bot to display the processed data on demand of the users. After the project completed, Docker will be used to containerize the entire application, ensuring seamless deployment. Last but not least, we'll deploy the project using AWS Cloud Service. This is all from me, and I'll pass the presentation to my teammate. Thank you.
Now, I will talk about the result. At the completion of this project, the developed system achieved real-time data collections, processing, and display through a dedicated Telegram bot. It successfully fetches real-time GitHub issue data using producer applications, processes it, then efficiently store processed data in MongoDB for later retrieval. After that, it will showcase the results on the Telegram bot interface. Leveraging the capability of Apache Kafka, MongoDB, and the Python Telegram bot library, The system offers scalable solutions for handling GitHub issue data. Besides, the integration of Docker further enhanced the system reliability by providing the containerizations, facilitating the easy deployment and ensuring consistent performance across diverse environments. In conclusion, this project demonstrates a seamless integration of Apache Kafka for real-time data streaming, MongoDB for efficient data storage, and Docker for streamlined containerizations. The synergy between these components enables a cohesive system capable of data collections and processing, and it also showcases the user interactions through the Telegram bot. The project outcomes underscore the significance of utilizing a combination of technologies to craft a cohesive and efficient solution for processing real-time data.
Hi, it's my turn now. Now I want to show the abstract structure of the system. Okay, what we can see is that producer application 1 and 2 handle different GitHub repository issues. The producer applications will get the data from GitHub repository issues and send it to Kafka topics in Kafka. Once the data is sent into the Kafka topics, Kafka String will immediately get the data and process it to get the word count and active commenters. The processed data will be streamed to Kafka topics. MongoDB will subscribe to the Kafka topics to get the processed data and save it to database. The consumer application is responsible for handling Telegram bot interact with the user. So the consumer application will take the data from MongoDB database and display to user through Telegram bot. We plan to put the entire system into a Docker container and deploy it to Amazon Web Services. Since what I am showing now is just an overview of the system, my teammate will show a demonstration of the system later. Please stay tuned.
Good day, sir, and my fellow friends. I'm Cheng no metric 2x6596. Now I'm going to continue for our user manual section. Before start testing our system, you need to setting up your system. First, you need to download the latest Kafka release, then start Apache Kafka using the zookeeper. Open the command prompt in the Kafka installation directory and run the command below. After a few seconds, the command prompt will print out the output indicates that the port 2181 is in use, and that means that your zookeeper is running successfully. Next, please open another terminal session and run the command below to start the Kafka broker service. After a few seconds, the output indicates that Kafka is successfully running on port 9092. After the Kafka is successfully running on port 9092, then you can create two Kafka topics to stream the GitHub issues data. Next, we can start to running the application. But before that, you need to configure the necessary parameters. Open the GitHub issues producer.py script and locate the following configuration parameters. The first, owner, make sure this variable represents to the owner or username of the GitHub repository. Second, the repo. This variable represents the name of a GitHub repository. The third, Kafka Bootstrap servers. This variable hosts the Kafka Bootstrap servers. As the default here, we put it localhost 9092. The last one is the Kafka topic. This variable represents the Kafka topic to which the GitHub issues. Now user can open a terminal window which navigates to the directory containing the script. You need to run the command below and please make sure that you have downloaded the Python on the device. Now user can check the output and the producer will continuously fetch and process the GitHub issues data. The program will run in an infinite loop and fetching and processing the data every 60 seconds. You can adjust the sleep interval in the script if you need it. For information MongoDB connection, in the MongoDB operation.py will done the connection automatically. The script established a connection to MongoDB using the PyMongo library. It connects to the GitHub Analysis database and two collections which are word count and also the active commenters. Next, the consumer. The consumer application will extract data from MongoDB and send it to the Telegram boot to display. To interact with the Telegram and run the provide boot script, user needs to install the Python Telegram boot package. You need to run the following commands below. After a few seconds, the user can access the Telegram bot through the link. Now here is our Telegram bot. They got total 4 options. First, start options is for user to start the consumer application. Next is active commenters, which are a list of active commenters. And third option, which are the list of words along with the count of times each word has been mentioned. And last but not least, user can view both active commenters and word count information by choosing the display both.
In order to simplify the implementation of our project, we install Docker Desktop for streamlined containerization. Once Docker Desktop is successfully installed, we can seamlessly proceed by running Zookeeper and Kafka through the command prompt, followed by initiating the Kafka Stream app. The next step involves building Docker image using the first command in the terminal. To run our project, we simply execute the second command, and just like that, the setup is complete.
My name is Hui, metric number 287982. Next, I will continue to demonstrate our system. Okay, to start the program, firstly, we need to start the Kafka environment. To start the Kafka environment, firstly, we need to start the Zookeeper service using this command. Zookeeper service has been started. After that, we need to continue with starting the Kafka broker service using this command. After that, we need to continue with running this producer application one to start the producer application. So based on the success output shown here, this producer application one has been successfully run. Next, we can continue with running this producer application too. So same with the producer application one, based on the output shown below, this producer application 2 has been successfully run. Next, we need to continue with running this Kafka Stream app. So based on the output shown below here, this Kafka Stream app also has been successfully run. After this, we need to continue with running MongoDB. Before we can run the MongoDB, we need to connect to a MongoDB deployment. And once successfully connected, we can run this MongoDB file. So based on the output shown here, this MongoDB file has been successfully run and data has been stored into the database. After that, we need to continue with running the consumer application. So basically, the consumer application is a Telegram bot application. So based on the output shown here, the Telegram bot application has been successfully run, or the consumer application has been successfully run. Our system already has some existing issue that being added before this, so we can try to input a command in this Telegram bot to view the list of active commenters and word count that has been stored before. Okay, once user input the command, the Telegram bot will display the list of active commenter and list of word count for user to view. Next, I will continue to demonstrate how to add new comment to GitHub issue and view the latest update of list of active commenters and word counts from a Telegram bot. Okay, we start the Telegram bot and then input the display both comment to view the list of active commenter and list of word count. So the list of active commenters for the first user, Looi 64883, is 17 comments. Next, we are going to add a new comment for an issue that handled by producer application 2. Firstly, we choose an issue and then enter our comment under the issue. Okay, comment has been successfully added. Okay, we move back to this producer application 2 since the comment we added just now is handled by producer application 2, and we wait for the update. Okay, so based on the output here, the newly added comment has been detected by producer application 2 and published to the topic. After that, the Stream app will get the newly added data from topics and analyzes the latest active commenters and word counts. After that, MongoDB will also get the latest list of active commenters and will count from the output topic of Kafka Stream app and update the database. After that, we can move back to our Telegram bot to view the latest list of active commenters and list of word count by inputting the comment.